Injection molding is recognized as the single most important form of plastic processing. Ensuring a high-quality, cost-effective, and efficient plastic molded part production process is critical to success. VISI's end-to-end software solution develops and validates your molding process to achieve high-quality parts that meet part print specifications. Let's explore the complexity, ingenuity, and sophistication our customers use to produce their molded parts utilizing Hexagon's VISI software. The injection mold represents a significant investment to develop products. The complex apparatus that will mold millions of parts in its life cycle results from hundreds of hours of different teams working together to create a functional, error-free, and optimized mold assembly ready for production. The use of technology to streamline the process will illustrate what mold makers can do to achieve success. Typically, mold makers receive 3D CAD data from their customers for the final plastic part design, complete with detailed specifications. VISI imports all major native CAD formats with flawless translation. Suppose the customer still needs 3D CAD or drawings of the part. In that case, VISI offers mold makers conceptual design tools to enable the customer to create precise 3D models of the part to specification and propose materials, equipment, and process solutions to suit their needs. Mold makers must interrogate the imported data to determine its manufacturing process and feasibility. They need to validate the quality of the geometry, check for defects, specify the required draft angles to allow part extraction, and confirm or modify the part thickness for uniformity to anticipate potential problems during the crucial injection phase. Next, they concentrate on creating the two halves of the part, technically called the split line, which separates the core and cavity. For simplicity, they are the top and bottom of the part, while the gap in the middle is the void filled during the injection phase with required plastic material. The split line is the line of separation on the plastic part where the two halves of the plastic injection mold meet. This plane can be a flat surface for a simple plastic part, but more often than not, it is a complex, stepped form that traces the perimeter of the part around the various features that make up the part's outer silhouette. VISI brilliantly offers many interactive and automatic tools to facilitate split line creation. With the split line defined, you can now quickly develop the parting surfaces using various techniques to divide the solid mold base into the core and cavity. These surfaces will be used later to shape the plates in the mold assembly. VISI's intuitive interface guides users to quickly and easily define the region where the electrode will be used to extract the shape needed to produce the required feature in part, and then edit the design to provide clearances and extensions. Dynamic animation and collision checking are available at any point within the electrode creation process. The electrode blank, base, and stock are interactively added to the electrode. VISI also generates all the required information for the EDM machine and a complete detailed drawing, if needed, to complement the information for your shop floor. The mold base is the main part of a mold as it provides the structural framework for the high-pressure injection process. It is assembled from diverse steel plates and parts and is readily available worldwide from standard suppliers. Typically, selecting an appropriate mold base for manufacturing a plastic part involves considering the number of cavities, insert dimensions, runner size, location, sprue, and gates. VISI offers market-leading, fully parametric, and user-customizable housing database solutions for a quick and effortless selection. Any change to the plate dimensions will automatically adapt any standard connecting components. These editable parametric templates include the default basic componentry, such as A clamping plate, B plate, support plate, ejector bar, ejector retainer plate, pillars, and bushings. Still, other templates exist for more complex mold assemblies. The next step is particular for each mold, allowing our customers to add all the necessary components to obtain a functional tool. Standard elements for mold making include ejector pins, sleeves, pillars, rods, pins, dowels, guides, springs, and many more. VISI offers the mold maker a vast library of off-the-shelf standardized components from over 35 different suppliers for intelligent placement within the assembly. The length of screws and other components will automatically adjust to suit differing plate thicknesses and rule-based parameters. Ejector pins are automatically trimmed to size to match the required 3D cavity form. These standard components are collision-free, cannot be placed in wrong positions, and are fully editable. As the number and type of these components increase, VISI retains the complete list and details of what to order from the chosen supplier. Standard mold components imported into VISI retain all the information as if created natively and automatically appear in the assembly manager and the bill of materials. VISI is leading the industry by providing its customers with state-of-the-art technology with direct access to cloud-based service that includes additional mold components or assemblies from an even larger pool of suppliers worldwide. Rapid cooling during injection molding can cause problems such as warpage, sink marks, and uneven shrinkage. That's why cooling is such an essential part of injection molding. When it comes to plastic injection molding, cooling is essential. That's because if the plastic isn't cooled properly, the final product will be deformed and won't meet the required specifications. Cooling channels can be easily inserted using a dedicated cooling wizard. Sketch the path of the cooling channel, and the wizard gives the designer complete control over position and sizes, providing automatic proximity checks to ensure cooling lines do not interfere with other tooling elements. Standard cooling line fittings can be easily inserted from leading supplier libraries. VISI prevents cooling lines from intersecting with the part or other components previously inserted. It also lets you decide which cooling lines should be plugged and which should be left open for the fluid to circulate. A full suite of editing functions let you control every cooling system detail. VISI also supports conformal cooling channels wrapped around the part rather than following a linear direction. This technique has a unique application since it requires 3D printing to be produced. We can now test our engineering efforts and validate that the mold will work and that the molded parts do not show defects or imperfections. VISI is the only integrated solution that offers these capabilities. This phase is crucial to identify and correct any potential problems before starting the actual manufacturing of our assembly. Any issue identified here will cost a fraction of the cost at any of the subsequent steps. To create a digital twin of the injection molding process, we use VISI to analyze the behavior of the molten plastic as it flows in the mold. Warpage and deformations are also predicted and measured to check for dimension integrity with the part specifications. Thermal simulations predict the behavior of mold cooling and enable us to analyze the cooling performance for alternative solutions. We can try out different circuit combinations and variations. Ultimately, the customer can also analyze how the temperature is dissipated throughout the mold assembly and determine the thermal effects on the plates and components surrounding the injection. WorkPlan monitors all manufacturing activity, schedules jobs according to staff and machine availability, and views and manages the status of subcontracted work. The digital availability of all manufacturing information goes a long way to ensuring team members know where to be and when. VISI provides mold makers with a fully integrated end-to-end solution for designing, programming, and manufacturing molds, plates, and electrodes for any CNC and EDM machine. Remaining in the same environment for tool path generation enables standard-driven automation for plate milling that combines best-in-class feature recognition, intelligent drill cycle association, and error-free programming. VISI's state-of-the-art 3-axis machining creates intelligent tool paths for even the most complex 3D parts. Dedicated high-speed milling techniques and built-in smoothing algorithms make highly efficient NC code. Intelligent tool path creation facilitates reduced cycle times for your machines, improving productivity to produce high-quality components continuously. VISI offers mold makers many advantages and efficiencies by employing a 5-axis for deep cavity and core machining with collision avoidance to automatically tilt the cutting tool away from the workpiece when required. Having been fully integrated, VISI offers flawless migration of data and information across the entire solution. Changes and feedback are immediately detected and included in the process. On the synergy front, VISI benefits from the great value offered by the integration of NC Simul. This synergy has pushed our predictive ability, offering a reliable digital twin to verify and simulate error-free manufacturing. Hexagon is developing smart manufacturing solutions that capture the knowledge of experienced mold makers. This built-in knowledge will empower the manufacturers of today and tomorrow. VISI helps to identify problems common to mold manufacturing early in the process before errors become costly. Connecting solutions in an end-to-end process decreases the need to juggle competing demands and reduces the stress of project management. Using a reliable system powered by data removes the guesswork from planning and manufacturing while ensuring each stage is a step in the right direction.